Let's wait. Hello. Hello, good morning. Just
Morning.
hello, morning. Goedemorgen. Okay, goedemorgen. I hope you had a restful weekend. Could rest a little bit, yeah, from the first week. So we start fresh this week, and of course we start with a lecture, and thereafter an exercise, and it will be about data entry. And also preparation steps in that's also part of it. So let's have a look what we will discuss. We will look at data acquisition, different techniques of data acquisition. Then we will look at digitizing from existing documents, mostly map documents, but you can also think about raster documents, an aerial photograph or something. Then some data preparation, that's the last stage, some error detection, those kind of things. Clean up your data, what kind of processes are needed to prepare your data. Basically, that's the lecture about. And I will also conclude with a demonstration in ArcGIS, how to digitize, and give you show you some tricks. Yeah. Yep. So in your book, they distinguish between direct and indirect data acquisition. What is meant with that direct data acquisition is the acquisition of data directly captured from the environment. That's the definition which is given. Yeah? And you can think of techniques like, and they are given there, field surveys, or you do a terrestrial survey, also aerial surveys. You can call it direct spatial data capture. If you like to know the details, they are in your textbook, but also in the next course, you will have much more details about these acquisition techniques. I think what is important to notice that these type of acquisition techniques directly captured from the environment are sometimes called primary data acquisition. What is meant with that? This is acquisition of data directly from the environment, but for a particular purpose, with a certain predefined quality. Yeah? And of course, you can imagine that if you acquire primary data, it might be quite expensive. Yeah? What you could also look, and that's the next thing, that's you can look at data which is already existing somewhere. And nowadays there's a lot of data available already. And you call that sometimes indirect data acquisition. That's at least given in your book. It's called indirect spatial data acquisition. Data is derived from existing sources, so from sources which already exist. Yeah. So you can think online sources. On the internet, you have a lot of options nowadays to obtain data, and it might be data which suits for your project. That depends on the quality, of course, and on the accuracy of the data, but there are many so-called geoportals which you can use to search for spatial data. And many times the data is freely available, it's without copyright, and you can use it. Yeah? And of course you need to know about the quality of the data, if it suits for your project. Yeah? But it's cheap, of course. And that's called secondary data in sometimes, because it's from a secondary source. Yeah? Also, when you use existing paper maps or existing raster documents, you can use it, you can scan a paper map, and you can, of course, trace features from it. Yeah? I would say that's digitizing from a secondary source. Yeah? So we may call this indirect spatial data acquisition. Yeah? And that's what we concentrate on now. Let's have a look at data from the if you acquire data from elsewhere, yeah, from another source, online source, yeah, then of course you have to know about the quality of this data. And what can help you with that is metadata. You know what metadata is? This is data about data. So that's the description of your data. And that is very important if you are searching for data, of course. You have to know about the accuracy. You may have to know about the data format in which it is available. You may have to know about the coordinate system, I would say. You may have to know, of course, about the content. Yeah? And if this type of information is called metadata. And you can, also in ArcGIS, there's an option where you can include metadata. You can edit metadata, and you can also look for the metadata. That's called the item description. I don't know if you're aware of it, but if you look at the spatial layer in your catalog, you right-click on that layer, and there's an option called, where is it? Item description. Here it is. Yeah? And if you select that option, if you are lucky, and if people really did their work well, and they documented the spatial data, then you can find there the information. Yeah? How accurate it is and those kind of things. Yeah? That would be nice. Of course, it's not always the case, but sometimes you see that they did it very well and very detailed. Yeah? This metadata is also important when you search for data in a so-called geoportal. Don't know if you know what a geoportal is, but there are many geoportals available at different levels, national level, even at international level or at organizational level. A geoportal is a special type of web portal that acts as a gateway to a collection of spatial data. So in fact you can search for data. But of course, if you like to use a geoportal, you need metadata. Otherwise, you cannot search. The whole search engine of this geoportal is all based on metadata. So if you have good metadata, a good description of your data, you may search for the data which you really need. Yeah? And a very good example is the National Geoportal of the Netherlands. It's the National Georegister. I think that's a nice one. Only problem is that this one is in Dutch. So maybe later on you will also do some exercises on these geoportals. But I might show you quickly how it, let me see if I have it here. You see this is the search engine of the Dutch National Geoportal. And you can select here, I don't know if you know that, onderwerp, what that means. That's a certain theme. Yeah? You can search for noise pollution, for example, and then the area Enschede, and then it will look for some possible available data. Yeah? Let's search, see what happens. What was this? Geluidshinder. Let's try that one. Yeah. Enschede municipality. Show results. And then from different organizations you can select them. So if you want them from the province of Overijssel, you can select them on that side. Yeah? And they are all connected. They all have their own servers where the data are located. And you can look at the data which you might like to, what is this? Is there anything interesting? Okay, noise pollution along main roads, yeah? That might be nice, yeah? And you can click on that, and you can find then all the information, which you can download the data. Here's a download button. But quite often, you can also make an online connection with a web server. Yeah, and then you just have to copy the link. Here you have a link with a web feature service. Here you have a link with a web map service. You see? what I can do now, I can just copy this link instead of downloading. I can copy this link. Yeah. Copy link location. Yeah. And what I can do then, I can go to ArcGIS. I hope it works. Sometimes, you know, when you demonstrate things. You go to the untitled, I have an untitled map. I go to catalog. And then I can here, I can add a web map server. Yeah. In this option, I can double click. And I can just put the link there. I paste the link. Yeah. And then I just say get my layers, and it gives me all the layers which are on that web service. This is about noise pollution. I can say OK. It makes the connection. Yeah. And I can, of course, use these layers and to view them. Okay, there's a web map service, so I can only view the layers. It's not a vector data, it's raster data it's a picture, but that might be enough in this case. This is the noise pollution along provincial roads. Just to see, you see, that's the information given. Yeah. Now, of course, you have to add a base map in this case, but that's possible because in ArcGIS you can just add a base map. And you just put maybe the OpenStreetMap, that's a nice one, I think. Yeah. And where is Enschede? There's Enschede, you see. And that's the noise pollution along the roads. It's given in different contours, yeah, colors. Only the projection is probably not okay, because if you use a VMS server, then mostly it's WGS84 data, unprojected. So in fact, if you want to, you should also go to the data frame properties, but you know about this, eh? And then you can just go to the coordinate system and assign, for example, in my favorites, the Dutch system. Yeah. Then I have a proper projection. Needs a transformation. Okay, let's do it. Yeah. You see? These are the contours. There's even, hopefully, let me see in this option if there is should be that there is a kind of legend. Yeah, there's the legend, and then you have a bit more idea. Yeah? About the pollution. This is the decibels, yeah, which I measured. It's online, so it's refreshing each time. It's up to date, yeah. It's quite interesting. But you might also download the data and do some analysis with it, of course, yeah. Okay, so that's about the portals. Then, spatial data from elsewhere is also digitizing. Yeah? Digitizing from existing documents. What does it mean? Digitizing means that you are having a map document, or you have a raster data set, could be an aerial photograph, and you are tracing features from it. So you factorize the data. You create, you have your raster data set, and you create vector data. Yeah? Lines or polygons or points. That's basically what you do. And how you do that? You do it by tracing. Yeah. And that's what we will also do in the exercise today. So let's have a look at this digitizing. What kind of techniques are available? There are different techniques available to digitize your documents, for example, a map document. One technique which is really outdated, which is not used anymore, that's on-tablet digitizing. Yeah? Then you have to manually trace your features, yeah, from a map which you stick on a tablet. Now, these tablets are not anymore, some organizations still use them, but in general, I would say they are not used anymore. Because what people mostly do, they scan their map, yeah, with a scanner, and then they can do it on screen. They can put it on screen, and they can just trace the features and factorize the features from the screen. Yeah? That's basically how you do it nowadays. And that's what we call on-screen digitizing. You see it here. You scan your document, or you have already a raster document. Yeah? In many cases, you have it already in raster. Then you put it on the screen, and then you use your cursor, yeah, better your mouse, let's say, yeah, your mouse, your cursor, to trace your features. And that you can do on screen, so with the image on the back, yeah. And that can be done manually in most cases when it's a complex document, but you may also think about software which can do it semi-automatically for you. So they can trace the features semi-automatically. Now in ArcGIS there's also software which can do that. It's called ArcScan. I will demonstrate it later. Yeah? So that's possible. Then there's also another possibility that you do it fully automatically. You don't do it from the screen. Yeah? The computer, you need software for that, of course, but it can trace it for you fully automatically. We call that automatic digitizing. So we have on-screen digitizing, manual, semi-automatically, and we have automatic digitizing. So fully automatic. So what kind of digitizing method do we have to choose? Eh? And I would say that depends very much on the complexity of your document. Yeah? If you have a very complex document with a lot of details, yeah? A topographic map, for example, at a large scale, then there's no way to do that semi-automatically. Yeah? That would, if you would do that, or automatically, it's not possible. Yeah? You would have a lot of errors and you would have to do a lot of editing. Yeah? So if you have such a, here you see a good example, a map with a lot of details, a lot of information, and you have to really trace this manually. Yeah? One by one, the lines you need, the points you need, and the areas you need, I would say. Semi-automatic digitizing is possible when you have a document which is rather simple. It might have different type of information, but not that much. I would say such a large scale, what is it, parcel map, which contains parcels, but it also contains buildings. So it contains two types of information, but it's not very detailed. Yeah, it's okay. And such a map, I would say, really would be useful to trace your features semi-automatically. It would be much faster. Fully automatic digitizing, then you really need simple documents with only one type of information. I would say a very good example are contour lines. Eh? They don't cross each other. Yeah? So if you would trace that fully automatically, you just press a button and everything is factorized for you. Yeah? Within a few minutes, I would say. Yeah? And there's not that much editing to do. All right? Any questions about this? No? Okay. Good. Then, before you start digitizing, what you first have to do, you have to georeference, or we call it map registration, georeference your map document or your photograph. Yeah? Whatever, that's the first thing you do. And for a map, you might use 4 control points, and you can use an affine transformation. Yeah? That would be enough. Yeah? If you have an aerial photograph, affine transformation might work, but sometimes when you have certain complex distortions in your photograph, you might use a higher order transformation with more control points. But for a map, I would say, you use 4 points, and if possible, you can use the map corners, yeah, and then you can just digitize or set up, georeference your map. So here I entered the 4 points, the 4 map corners, the map coordinates, of course, yeah, of the map, and then what will happen after I entered the 4th point? I can see my error, my root mean square error, you see? It gives me here a root mean square error for my affine transformation, which I applied. And of course, the first question is always, is this good enough? Yeah, that's the first thing. What is it? It's about 1 meter, yeah? 1 meter for this map. Now, what do you think? Is that good enough or not? I explained it a little bit already last time. It's not. 1 meter is not good enough. Now you have to relate it to the accuracy of the map, yeah, and also the scale is involved then. So now we have to look 1 meter at the scale of the map. How much is that? Yeah. What's the typical accuracy of a map document? If you have a topographical map, what's the typical accuracy, standard accuracy? 0.5 millimeters? I don't know what's in your country, sometimes even better, but let's say on average, typical error of 0.5 millimeters. That's the accuracy of a map document, yeah? Now, is this 0.5 millimeters, this 1 meter? We have to relate it to the scale of the map. So 1 meter, what's the scale of this map? It's 4,000, 1 over 4,000. So 1 meter at scale 1 to 4,000. How much is that in millimeters? Scale 4,000, 1 meter. What is that on the map scale? 1 meter. How many millimeters? So 1 meter divided by 4,000 will give you 0.25 millimeters. Now, if you have a standard of 0.5 millimeters for your map accuracy, then this is within the accuracy of your map, 0.25, yeah? So I would say it's acceptable, yeah? All right? Good. Now, then you start digitizing. Once everything is georeferenced, then you can start digitizing. There are two modes too of digitizing. You can use the point mode. Then you have to trace each coordinate of the line, so each vertex of the line or of the area of the polygon. You have to trace it manually. Yeah. So here you have a line, and all the points which are given here are selected manually. All the coordinates of the line. Yeah. There's another way of digitizing, it's called stream mode. That means you just follow the line, yeah, with your cursor, and what it will do, it will automatically record points or coordinates, we call it vertices. It will automatically record these coordinates for you, yeah, depending on the deviation from the straight line. Because when it's a straight line, do you need then a coordinate in between a straight line? No, better not if it's a straight line. But when you make a curve, of course you need some points, yeah? So stream mode is a bit dangerous. It's also sometimes not so accurate because you have to set the stream settings very well. Otherwise you will end up with too many points, or you will end up with points which are not enough to represent the line or the curve, yeah? So I would not recommend to use stream mode, but sometimes it might be handy for contours or whatever, yeah? And you can do that in ArcGIS with the F8 button, yeah? Then you go from point mode to stream mode. Try it, I would say, yeah? Then some digitizing tips, yeah? You should use snapping. Why? Otherwise your points or your lines are not connected, yeah? And you will create overshoots and undershoots. I think that's a very important rule. There are snapping options. You can define them in ArcGIS, and that will then automatically snap to an existing point or an existing line. So this point will be automatically jumped. So this coordinate will be jumped to this intersection, yeah? If you are close enough. That's called snapping. Yeah? If you don't put any snapping options, then you might end up with overshoots, or undershoots, gaps. Yeah? And then you don't have very nice, clean intersections. Also, you should avoid to duplicate lines. If you have areas, you have here a common boundary, yeah, between those two areas, but you should not digitize it twice, because then you end up with sleevers. We call that sleevers. So we have here two lines, and then you end up here with a polygon, which is not really a polygon, yeah? It's a sleever polygon, and it's an error, and you have to be careful with that, yeah? Not to do this. Then snapping, yeah, the snapping tool in ArcGIS, yeah, when you are at an intersection, like here I'm digitizing the railway, and there at the intersection I will stop my line. So here a node is created, yeah? Or the endpoint, sorry, node is not, but it's an endpoint, yeah? And then I use the snapping function, and there are different snapping options in ArcGIS. You can use the point snapping, that snaps to a point, the end snapping, that snaps to an end line, yeah? And you can have the vertex snapping, that snaps to a coordinate, any coordinate, yeah? Which is in your line. And the edge snapping, that snaps to an edge of a line. So in this case, I need at least the end snapping. You see, I put the end snapping on, and then I can connect this line, and I can continue. And it will automatically connect it properly. You can see that it automatically jumps to this line, this endpoint, because I put this endpoint snapping on, and then I can just continue, yeah, with tracing my railway, yeah, here also. That's basically it. Yeah. Good. And there you can create a node later on if you do networking or whatever. You can automatically generate nodes at these intersections. That's quite easy and handy. Yeah? If you stop there and define it as an intersection. Yeah? Now then are some other tricks. If you have polygons, you can digitize them, of course, with the polygon mode, polygon construction tool. That's the tool which you normally use. But if the polygons are not, if they are connected, here you see two buildings, and what do you notice? They have a common boundary, you see? Yeah? And if you digitize this with the polygon construction tool, you digitize these two polygons as two separate polygons. What will happen if you zoom in? A gap, you see? Or a sleeve, a polygon. Because you digitize this line, this boundary twice. And that's what, you should not do that, yeah? You should digitize the same geometry. You can use, of course, the snapping to avoid that there is a gap or a sleever. But there's another tool in ArcGIS which is quite handy. That's the autocomplete polygon construction tool. And you see what I do? I just digitize this part of the building. This is the existing polygon already. Yeah? Digitize this part of the building, and it will automatically close the polygon using the geometry of the existing polygon. Quite handy tool. You will use it later on also. Yeah? I may demonstrate it for you. Then if you start digitizing areas, yeah, to obtain polygons, then sometimes it's rather complex to digitize these polygons one by one. Especially when you have complex polygons which are adjacent to each other and they are very large, then it might be easier to digitize area objects as lines. And afterwards you can construct the polygons. And that's what I show here. This is quite complex. This is a land cover map. And the roads and all the roads are very complex. Also these areas are rather complex. So what has been decided to do, to digitize first, yeah, the line work. So the lines of the areas. Yeah? They are not directly digitized as points, but just as lines. Sorry, they are not directly digitized as areas, as polygons. Yeah? They are just digitized as line work. And you see that here with small overshoots, because if you use overshoots here, it can automatically construct the polygons. Yeah? So I show you what happened. Yeah, you see? This road, which you see here, this road is a very complex road, you see? It is in fact a polygon. But what is done here is just digitizing the outline up till here, then the next line up till here, then here, and later on the polygons will be constructed. Show you how it works, like this. This line is then digitized. We don't digitize them directly as polygons. Look. Everything is just digitized as lines. Do you notice that? Yeah, that's it. Yeah? And that's in fact line work. And then there is an automatic procedure which is called feature to polygon, which you may use to construct the polygons automatically. And that can be done very easily. Yeah? And then what will be the result if you do that? Hey, there's a problem, eh? What's the problem here? Put an undershoot, you see? What will happen? Probably there's no polygon constructed, yeah? In that case. So let's have a look. Yeah, the polygon is gone, because these are my polygons. Yeah? So it looks nice, I would say, except for that one polygon, which I have to create again. Yeah? So now I have my polygon map. And what's the next step? In fact, I can associate attributes to the polygons. Normally when you digitize, you can do the attribute entry at the same time as you digitize. But here, after you created the polygons, you have to enter the attributes. So yeah, you have each polygon has its own object idea, and then you can add the attributes manually, in this case, of course. I have a problem here. What is this? 2 polygons with the same ID number. That's a bit strange. And there's a missing ID number, so these things you have to solve if it happens. Yeah. And then you can continue. Now that's about digitizing. Yeah. Sometimes if you do, I told you, if you digitize and you digitize from the screen or you do it automatically, of course you have to scan your document first if your document is not digital yet. Yeah? So for that you need a scanner. Yeah? And there are many different scanners on the market which you may use to scan documents. If you want the highest quality, then you really need a drum scanner, yeah? Or a high-end flatbed scanner will also give you very high quality. Yeah? I would say for large format maps, you may also use a FAT scanner. There's this type of scanner. Yeah? That's also a possibility. So once you scan your document, what do you have to do? You have to define the resolution, yeah, the pixel size of your document. Yeah? That's important. Yeah? And also the mode. Do you scan it in black and white or in color? Yeah? So the pixel value also. So here you see it. There are 2 things you have to define before you scan your document. The scanning resolution, and we call it the scanning modes. So scanning resolution is in fact the pixel size. Yeah? What should be the pixel size? Yeah? And that can be expressed in different ways. You can express it in millimeters. Sometimes it's expressed in microns. But many times you see that it is expressed in dots per inch. DPI, dots per inch. Dots means in fact the number of pixels per inch. And an inch is 2.54 centimeter. Yeah? So how many pixels does 2.54 centimeter contain? Yeah? Now here you have, for example, DPI 500 pixels per inch. Yeah? 500 dots per inch. Yeah? That could be a scanner resolution. Yeah? And here as you see the document, the lines which are resolved by means of pixels. And here the size is 0.05 millimeters. Yeah? That's the scanner resolution. The scanner mode, that mainly depends on the document. If it's a color document, you would use color mode. If it's a grayscale document, you can use the grayscale mode. So in fact, that's the pixel depth, the pixel value which you obtain. Yeah? If you scan in grayscale mode, your pixels will range from 1 to 255, yeah? The pixel values. Yeah? In color, you have 3 colors, yeah? Red, green, and blue. Yeah? For red, for green, and for blue, you use 1 byte, so from 0 to 255, and that gives you your color image. That's basically how it works. Yeah? Now, once you have defined that and you scanned your document, yeah, you can do the digitizing. How? That depends. You first have to choose what technique are you going to use, yeah? And depending on the technique, you also have to scan your document with a certain resolution. Yeah? Can you understand that? If you do manual digitizing, a paper map, then the resolution of 200 to 300 dpi would be fine enough. That would be good enough. Then you can trace your lines manually. Yeah? If you scan aerial photographs, then of course you need very high resolutions because you have a lot of detail, and to show that detail you need at least 800 dpi or larger. Yeah? What about semi-automatic or automatic digitizing? If you apply this technology, that means the computer has to trace the lines, and the computer has to trace the center of the lines. Yeah? If you like to apply this technology, then you need slightly higher resolutions for your map document. Here I put it. Your printed map should be between 300 and 600 dpi. Yeah? Because you have to resolve your lines with enough pixels. Otherwise, the computer cannot trace the center of the line. Can you imagine that? That you need enough pixels for the lines? I show you that in the next example, where you have, is it this? Yeah, where you have the lines which are here. Here you do the computer is doing the tracing. And what you see here, one line is only resolved with 2 pixels. Yeah? And the yellow line is the vector line. Yeah? So that's the vector line. And what do you notice? That the yellow line is a little bit displaced. Do you notice that? Yeah? And that will happen if you let the computer digitize this line. It will give you slightly displaced lines. So in this case, yeah, it can really follow the center of the raster line. Because in gray you have the raster line, and in yellow you have the vector line. Yeah? And that can be then more accurate. Yeah? So vectorization, the conversion from raster to vector, how you do that when you do it automatically? The computer does it, I show you that. This is your scanned document, your line work. And what the computer first does, if you apply it, it applies a technique called skeletonizing. It will, it will thin your pixel lines. This is your line work after scanning and with your pixels. And the first thing what the computer does, if you do it automatically, it will do the skeletonizing. You see? What did it do? It will peel off 1 pixel from the lines. And it will continue peeling off these lines till it has 1 single pixel. Yeah? So look at it. Yeah. Is it enough, or it has to peel off more? There's still 1 line which is resolved by 2 pixels. So it needs a single pixel line. So what it does, it will run the skeletonizing again. Yeah? This terminology skeletonizing is used for that. Yeah? And then you have your line work. It's still raster, eh? Yeah, but this is one line, 1 pixel. And now it can vectorize it. So now the program can easily make a line work from it. Yeah? See? Red are the vector lines. But what do you notice if I show you the vector lines only? There's some problems. Eh? Here at the intersections, there's a T-junction which is not very well captured. Yeah? Some lines are not captured so well. There are some points which should not be there. This is dirt on your document. So very often you need some cleaning, but the software has, mostly of the time, this software is able to clean these errors, and it can, after post-processing, so after cleaning, you have a good line work. Yeah, you see that T-junction. This is an X-junction which is not properly captured. Some spikes here, and this is a T-junction. Yeah, but here a corner which is not a right angle, but the computer can solve this for you. That's not really a problem. Yeah, and then of course you have your line work as you like it. Yeah, automatically. Yeah, this is not manually. What's the next step? Is there one step left? Yeah, you have lines, but it's not structured. So you have to create intersections. Yeah, you have to split your lines and assign attributes. Of course, you have to. We call it feature forming. Look what I do. What has been done here. There are nodes on the intersections, and all the lines have now proper attributes, proper codings. Yeah, and that would be then your final step. Good. Now, there are possibilities to do this semi-automatic vectorizing or automatic vectorizing in ArcGIS. And we call that options, ArcScan. There you can apply this. I may show it you, then it's more clear, I think, for you if we have a look at it. Let me demonstrate it to you. Yes. We have time? Yes, we have some time. Yeah. So some line work. So what I need ArcScan. That's one toolbar. You see that? If you want to activate, you first have to customize the extension, because it's an extension. I have to say, okay, I like to use ArcScan, so I have to select the extension. And then I can, of course, go to the editor. I need also the editor, otherwise I cannot start, of course. Editor. I start the editor. Yeah. And then you see there's one option here, which is in fact generating features inside an area. That's fully automatic digitizing, this option. Yeah? If I apply that one, I can trace an area like this, and then it will automatically create the vector lines. You see? There are the vector lines already. But you see there's quite some errors, so we need to do some editing, and that may take more time than doing it manually. Yeah? So in this case, I think it might be better, if you like it, to do it semi-automatically, or maybe, and that's also possible. Edit, undo, move, yeah, that's done. Then I have to go to the editor again, but I have to go to this, where is this tool? Let's try this here. This Create Features tool. That's the tool. And then I can click on the lines. And then I can use this option. Vectorization Trace. And that one I can do then automatically. Then I can just click here, one line, for example this line. And I have to tell him which direction it should follow, you see? I can just click here, follow this direction. Why it's not working properly? Bit strange. Yeah, now it comes. You see, it traces this line automatically, and here it has a problem. It doesn't know how to continue. You see, there's an intersection, and you have to resolve it yourself. So I can use press the S button, and then I can digitize it manually. See, now I can digitize my points manually. So until here maybe, and I can tell the computer, okay, now continue. Yeah? I click here, I release the S button, and it will continue up till here. There's a problem, So what it should do now, okay, I tell him, put the S button, digitize a few points here. Now it should know, and it could continue, hopefully. Yes, there is a problem. So now I have to do that myself. And you see, this can really speed up the digitizing. Just to show you this. Yeah? Now let's finish this part. And there you have it, your line work. Zoom to layer. Yeah? Okay? Yeah. Good. That's about. Now then data preparation, that's the last step. These are cleaning operations, but not only cleaning operations, but also, for example, polygon forming and those kind of other things which you have to do after digitizing. Yeah? So here you have it. Now here you have a number of cleanup operations. They are given in your textbook. And these are cleanup operations which are very often needed when you make mistakes. And they can be detected by the computer, most of these ones. And it can also be cleaned by the computer. There are cleaning tools which you can use to clean these problems. Yeah? Dissolving polygons, that's possible because this boundary is not needed. So now you have one polygon formed out of this. Here you have undershoots with gaps, and you have overshoots. Some of these cleanup operations, if you want to apply them, you need to define a tolerance. We call it the cluster tolerance. Yeah? And that's important. This cluster tolerance is very important to avoid undershoots and overshoots, and you want to clean it. Then you have to define a cluster tolerance. I show you what it means. So here, for these operations, you have to define the area which is used for snapping. Yeah? What does it mean, cluster tolerance? Points within the cluster tolerance are moved to the same location. Yeah? So everything within that area will be snapped together. And if you make that area too big, what will happen? Your line work will be displaced. Yeah? So you have to be careful not to make the cluster tolerance too big. How big, how large should this cluster tolerance be? It should be at least 10 times smaller than the accuracy of your data. So when your accuracy of your data is 1 meter, you should define a cluster tolerance, if you like to clean your data, of, let's say, 10 centimeters. But not more. Yeah? So 0.1 meter then. Yeah? So keep that in mind. Yeah? Here you see, I think, a nice example where I applied a cluster tolerance to clean this polygon, because this is a sleeve polygon, a very small one, which should not be there. Yeah? And I cleaned it with different tolerances. The gray lines, there I cleaned the line, this polygon with 50 meters tolerance. And with the red line, I cleaned it with 80 meters tolerance. Yeah? And do you notice the displacement of your lines? Yeah? With 50 meters, it is displaced, but not so much. You see these lines, yeah? The gray lines. With 80 meter, the red line, it's already quite a big displacement. Yeah? Here. This is a displacement of about 10 meters. Here it's 20 meters. Yeah? Is this allowed or not? Is this allowed, 10 meters displacement? Yes? No? It depends on the accuracy of your data. Yeah, scale in this case, not accuracy, I would say. Yeah? Yeah? Now, what you can do then, after you clean up your data, you can of course structure your data more. Yeah? You can form polygons. Yeah? From line work here, you can snap it. You see there are the nodes created at the intersections, and you can create, of course, a polygon data structure. But you can also create an arc node data structure, a topology data structure. You know about that, eh? Ms. Elohim explained that to you. And such an arc node topology structure is sometimes quite handy also for editing. For editing purposes, we sometimes use this arc node topology structure instead of the polygon data structure. Yeah? I show you that. For example, if you like to edit shared boundaries, we can use the map topology editing tool in ArcGIS. That's a tool which can be used to edit boundaries which are shared together. Yeah? Like here, if we use the standard editing tool, we like to get rid of this. This should be straightened. Yeah? And if I use the standard editing tool, what will happen? I will create a gap. Because in fact, these two polygons, adjacent polygons, they have their own boundary. Yeah? And if I just do it with the editing tool, it will create a kind of gap. Now, with the map topology editing tool, I can click on this line. It becomes purple. That means ArcGIS is creating on the fly a topology structure. Only temporary. Yeah? It creates an arc node topology structure. And if you then do the editing, see, create it on the fly, then of course there's no gap. And that tool is quite interesting sometimes to use. Something else, the geodatabase topology. That one can also be used to clean up your data. You specify some rules inside for certain feature classes or between certain feature classes. You can specify topology rules, like for example here, the polygons should not overlap, or the polygons should not have gaps. You define those rules here, and then you just, the computer can validate those rules. It will create a so-called topology layer, and it will validate those topology rules. And it will automatically clean the errors depending on the tolerance. So if you make the tolerance very small, it will not clean your data, it will just show you the errors. And you can correct them manually with the so-called error inspector. That's possible. So then it shows you the errors and you clean them or you edit them manually. If you make the tolerance big, it will probably try to correct those errors automatically. That's about geodatabase topology. A very handy tool. You will use it in the exercise today. Now here's some cleanup operations. To start with, I have here line work. What I have here, a few overshoots and undershoot. So what I did, I created geodatabase topology and I added some rules to it. Must not have dangles, must not have, must not intersect. And then of course I knew what errors there are and I can clean them or manually edit those undershoots. I added these undershoots, this one, manually with the editor. But the overshoots I don't have to edit because I'm creating polygons that will be done automatically. Here is another undershoot downstairs, I edit it. And then I have here some overshoots, but that's not a problem. I have here some pseudo nodes. These are nodes which are not actually nodes here. So I can drop them, merge to largest. Then there's one line. And then I use the feature to polygon tool. That's the tool you can use to create your polygons. What else I did here? I checked for small polygons because that might be a sleever polygon. So what I did, I went to the attribute table, looked at the shape areas, and you see, there's one very few small polygon. And I didn't notice that one, but now in the attribute table I can find it. And then I see, hey, that should be an error. And that's this sleever polygon. And I can correct it automatically, of course, but in this case I think I did it manually. Yes, I defined a rule for it, but then in the end I edited it manually, this line work there, with this sleever polygon. And then what I did, but you don't have to do that, I created here some centroids from the polygons. And then I had an attribute table, I connected it to the centroids, so I attached the attributes to the points. That's what I did. And then I transferred the attributes from the points to the polygons. But that's a bit complicated, you don't have to do that, but I did it with a spatial join tool. And now my data is ready. Okay? That's possible. Just to show you quickly. Now then there's one thing left, that's a combination of data from different sources. If you have data from different sources, I told you that's nice because we have a lot of freely available data nowadays, but they might have different accuracies, and they might have different detail. And you have to do cleanup operations to merge them together. And that's what is meant with this. So data can come from different sources and they might have, there you have it, differences in accuracy when you overlay them, differences in detail, differences in the coordinate system, so you might have to do some coordinate transformations first, differences in area coverage, and then you have to, here you see there's some We call it horizontal integration. There's some edge merging done. These three are combined together. You have done it in exercise 3, yeah? For the roads, I remember. Friday, yeah? Kind of edge matching, but not really because they were fitting already. Yeah? So, here, and that's the last thing, I show you a few, a procedure for editing, which is defined by a project. That's the UN SALP project. And they created a procedure how to edit the administrative boundaries of African countries. So for the entire continent, they defined a border, an international border. This is an official UN border. And they compared it with the current administrative boundaries. Yeah? And then they noticed that they didn't match. Yeah? The legal boundary did not match with the administrative boundaries. Yeah? Because they captured it in different ways, yeah, from different sources. So they had to find a procedure to clean up the administrative boundaries. And they defined this, and in the end, you see they have the cleaned up boundaries. So this is the input, yeah, and also the administrative boundaries are the input. And how they did that, I show you that. There were some cleanup operations defined. But what basically is the idea that the administrative boundaries are moved, yeah, towards the international border. So you see here the international border in red, and the administrative boundaries are moved. When they didn't overlap, the boundaries have to be moved, yeah, across the international border, and after that they clipped the administrative boundaries. Yeah? So this is then the edited result. So all the administrative boundaries are now matching with the international border. And it's a nice project where you see that there are many different cleanup operations applied, yeah, to come up to one, yeah, standard product with a predefined quality. Yeah? Okay. Yeah. Good. Class demonstration. Yes, I will demonstrate a few things. Yeah? But let's take a 5 minutes break. Okay? Good.